Look, guys, this is number 4 for unit 4. So in this one, we have a mass, a 1 kilogram mass, as attached to a spring. So I have mass equals 1 kilogram. Remember, kilogram is a mass unit, so you don't have to worry about trying to solve for slugs or getting into another form. You can leave it as just kilogram. And the spring stiffness is 8 Newton per meter, which wrote as K. And a damping constant, which is B, is 4 Newton seconds per meter. The mass is pushed upward. And I made this note here. Since in the other problem we said downward is positive, I want to go ahead and say for this one downward is also is positive. But that's just me making my note. If they don't specify, you can decide which direction is positive. I think they'll say downward is positive on their test. Another problem it specified, but in this one it did not. So make whatever decision you would like with it. You'll just be a sign off for your answer. Is the big difference. So since it said downward is positive, and we have an up, and the mass is moved upward 2 meters, that means that since up is downward is positive, upward is negative, that means y of 0 is negative 2 meters, and is given an initial downward velocity of 10 meters per second. Since it's downward, it's positive 10 meters per second. There's no external forces, meaning f of t is 0, which I love. And now I have to solve for the equation of motion. Remember, the equation of motion is just y of t. So now I'm going to go ahead and plug all these different variables in. So we're going to have y double prime over times our mass, which is just 1, plus b times y prime plus 8 times y equals 0. Remember, you can use Laplace or y sub h, y sub p to solve for your y. I prefer the second method just because I don't have anything on the right side. Whenever there's something on the right side, then that means I have to solve for y sub h and a y sub p, but if it's equal to 0, then all I have to do is solve for y sub h, which is really nice, and we're given initial conditions, so we don't have to worry about that as much. So I just like to solve for y sub h, so which I'm going to is go ahead and do. So I'm going to get this into the auxiliary form, so r squared plus 4r plus 8r, just 8 equals 0. And then this implies our roots r1, r2 equals negative b, which is negative 4, plus or minus the square root of b squared, 16, minus 4 times a, which is 1, times c, which is 8, so 4 times 8, 32, all over 2 times a, which is 1, so 2. This will equal negative 2, plus or minus, we have 16 minus 32, which makes this the square root of negative 16, which makes this equal to 4i. We have 4i divided by 2, which is 2i. So then this implies alpha equals negative 2 and beta equals 2. And this means that our y sub h, or our y, I was going to say y sub t, equals c1. I'm going to multiply all this by e to the alpha t first. So e to the negative 2t times c1, and we can choose sine or cosine, doesn't matter, beta t, which is 2t, plus c2 cosine 2t. The reason why this doesn't matter, because either way, we work it out, it will match up with the corresponding trig term. So now how we're going to go about this is we're going to say, since we have our y, we can say now that y of 0 equals negative 2. So if y of 0 equals negative 2, then that means e to the 0 is 1 times c1 sine of 0, which goes to 0, plus c2 cosine of 0 goes to 1, which implies c2 equals negative 2. Do the same thing for y prime of 0. We'll solve for y prime of t real quick. Y prime of t is negative 2e to the t. So I'm going to do a product rule with this left term times this whole term. So negative 2e to the negative 2t times the derivative, or times the regular term. So sine 2t plus, oh, that's not 4, that's a c1. my bad, C1 sine plus C2 cosine, 2t, and then plus 2e, oh, not 2, I keep writing 2, just erase. There we go. E to the 2t, and then times the derivative of the other term, so it means we're going to get 2c1 cosine 2t minus 2c2 sine of 2t. Then we can put 0 in for that term. So since we said y prime of 0 equals 10, we substitute 0 for our y sub prime, which is going to be negative 2 e to the 0, which goes to 1, times c1 sine of 0, which goes to 0, plus c2 cosine of 0, which goes to 1, and then plus e to the 2t, e to the 0, which goes to 1, times 2 c1 cosine of 0, which goes to 1, minus 2c2 sine of 0, which goes to 0. Alright, I'm going to clean this up a little bit. So then 10 equals negative 2 times c2 plus 2 times c1 and c2 equals negative 2. So that means c1 will equal 10 minus 4 all over 2, which equals 6 over 2, which is 3. Which makes our overall equation y of t equal to e to the negative 2, negative 2 cosine 2t plus 3 sine 2t. Now, is the system underdamped, overdamped, or critically damped? So, remember from the other problem that I did, let's look at the b squared minus 4ac. If it's greater than 0, overdamped, less than 0, underdamped, and if it equals 0, critically damped. So as we saw before, this is 16 minus 32, which equals negative 16, less than 0, therefore underdamped. Now the damping factor. Damping factor is our a e to the alpha t. Where alpha is equal to negative 2, and a equals our coefficients combined together in this manner. So we got c1 squared plus c2 squared, which will equal square root of 2 squared plus 3 squared, which equals square root of 4 plus 9, square root of 13, which implies our damping factor is square root of 13 e to the negative 2t. Now our quasi-frequency, this is omega over 2 pi, where omega equals beta, so that implies 2 over 2 pi, which equals 1 over pi. That's our quasi-frequency.